Today we're going to continue our study on graphs of functions. Particularly today we are going to talk about how we can graph piecewise functions, and we are also going to talk about what we call parametric functions. So in terms of graphing piecewise functions, we know how to evaluate piecewise functions. Now we need to know how we can go about graphing them. So one way you can go about graphing these is you can graph each part. So for example, graph x squared, you know that's a parabola facing up. But only take the piece of the function that applies. So here, for example, this only applies when x is less than or equal to 1. So you want to only take the portion of the graph that's less than 1 all the way up until it equals 1. You can do the same with the second piece, so y equals x plus 2. That's a line with a slope of 1 and a y-intercept of 2. You graph that line and you only apply the portion of that graph that applies. So x can be between 1 and 4 and it can equal 4. So you'll notice that solid portion that I've drawn is the part that actually applies. Now when you actually go about graphing these piecewise functions, you have to graph them in the same graph. So here we are going to go ahead and put those two together, and so this would be the graph of the piecewise function. Now notice here that I've very specifically placed those points. So for the parabolic portion, I put a point at 1, 1. That's where it ends. Now for the second piece of the function, it's not equal to 1 there, so I have to put an open circle. But we do need to know what's happening at that point. So when x equals 1 in the second piece of the graph, you would have 1 plus 2, which is equal to 3. So 1, 3 is where that point is, but we have to draw it in as a whole. It goes all the way up to 4 and includes 4, so we are going to put a point at x equals 4. So generally with piecewise functions, this is a good way to go about it. Just determine what each piece looks like and only take the portion of the graph that applies, depending on what it tells you for your value of x, and then combine it into one graph. All right, so here's another example. F of x equals negative x and f of x equals x. So in the first one, f of x equals negative x, that is a line with slope of negative 1 with a y-intercept at 0. So that's what it looks like, but this only applies when x is less than 0. So notice the solid portion of the graph is only on the side where x is less than 0. Do the same with the second piece of the graph, f of x equals x. That's a line with slope of 1 with y-intercept of 0. And this only applies when x is greater than or equal to 0. Now when we put those two together, they actually do attach in this particular case. They don't always attach. And we can combine those two pieces together, and actually this is a way to describe the absolute value function using a piecewise function. Now let's talk about parametric graphing. In parametric graphing, we have x and y coordinates of each point on the graph that are defined by a third variable, which we call t. We call t a parameter, hence parametric graphing. Normally, the way that we have been graphing is that y is always dependent on x, and x is the independent variable. But now both x and y are going to depend on the parameter t. So take this curve that's given by x equals 2t plus 1 and y equals t squared minus 3. How do you go about graphing this equation? So on your graphing calculator, if you find mode, and then on the fourth line down, or it might depend on your calculator, you want to change the mode from function to parametric. So now if you go to your y equals, you should have two things. So under y equals, now you should have x1 with a little t next to it and y1 with a t next to it. And now you can plug in your equations. If you use normally the button that you use for X, the one that's next to the alpha button, in parametric mode, this will automatically be a T when you click on it. Now you may need to set your window. Now you'll notice the window looks slightly different, and really what you're doing is instead of giving the X-min and X-max, first it asks you for the T-min and the T-max. And here's what your graph should look like. So this is actually just the graph of a parabola. All right, so now if you have a graph y equals f of x, in order to be able to graph something in parametric mode, you will let x equal to t, and then y equal f of t. If instead you have x equals f of y, and you want to graph that in parametric mode, then you'll make x equal f of t and y equal to t. Let's take a look at these examples. Graph the following equations in parametric mode on a calculator. So in this first one, we have y in terms of x, so we are going to let x equal to t, and then we let y equal, and then all you have to do is replace the x with t, so t minus 1 over 2 squared minus 3. Now, if you were to graph this, you will end up with a parabola. In the second one, you see how in this one we have x in terms of y, which is different from the first one where you had y in terms of x. So this time you set y equal to t, and then you set x equal to t squared minus 3t plus 1. Then when you graph this, you'll end up with a sideways parabola, and this is something that you would not be able to graph if you were in function mode, because we know that this is not a function. And so now you can see how using parametric mode is helpful in order to be able to actually look at the graph.